Step 1. The Rube Goldberg machine starts as I burn a green string with a candle. The string is attached to a wide piece of metal where there is an already compressed spring in between. The thermal energy from the candle burns the string and transforms into elastic potential energy, which initiates step 2. Step 2. The spring behind the metal releases as the green string is burned and pushes the bouncy ball and marble in front of it on a road. Elastic potential energy from the spring is transformed into kinetic energy, which causes the two balls to move. Each ball initiates a different step. So first I'll explain how the bouncy ball takes part in the Rube Goldberg. And step 3, the bouncy ball goes down a ramp and falls to the ground. The gravitational potential energy of the ball transforms into kinetic energy as it rolls down the ramp and falls to the ground. Step 4, the bouncy ball will then bounce off the floor into a paper funnel. As the ball hits the floor and bounces off, the kinetic energy of the falling ball transforms into elastic potential energy, which causes the ball to bounce back up. When the ball bounces back up, the elastic potential energy transforms into kinetic energy, which then the kinetic energy converts into gravitational potential energy as the ball rises up in the air. This gravitational potential energy of the ball causes it to fall into the paper funnel, converting it back to kinetic energy. Step 5, at the bottom of the funnel there are two wires which are connected to the speaker. So when the ball falls down, it sits right on top of the two wires and acts like a switch and turns the speaker on. In this step, the kinetic energy of the falling ball transforms into sound energy. Step 6, as the speaker is now turned on, it plays a loud song, causing the stick in the tube in front of it to vibrate forward. Here, the sound energy from the speaker transforms into kinetic energy, resulting in the motion of the wooden stick. Step 7, the wooden stick is touching the first domino, and as the stick vibrates, the first domino falls and sets off a series of dominoes. Step 8, the last domino to fall falls directly on top of a lever, which acts like a barrier for the marbles on the other side. The last domino is actually two dominoes glued together, so that it has enough mass to move the lever. As the side of the lever goes down, the other side goes up and lets go of the marbles. Step 9, the now free marbles move down an inclined plane where the gravitational potential energy of the marbles transform into kinetic energy. And step 10, at the end of the inclined plane, there's a tube that opens up into an ice cream tub filled with water. It has a hole which is connected to a straw, and the water is filled up to the hole. So when the marbles start to fill the container, the height of the water increases and it displaces into a bigger bucket. Step 11, the bigger bucket is hanging on a wooden scale where there are two buckets filled with water. So as more water flows into this bucket, its mass increases and it starts to go down. There's this clothespin underneath the bucket, so when the bucket is low enough, it presses onto the clothespin and opens it up. Step 12, the clothespin is holding a metal hoop, which is tied to a string that also is tied to the mousetrap catapult. So when the clothespin opens up, it releases the string, and thus the catapult throws the tea bag sitting on the spoon attached to the mousetrap into the mug. Here, the elastic potential energy stored in the spring of the mousetrap transforms into kinetic energy. So now there's the other side where the marble at the beginning initiates other steps. So step 13, the marble moving on the road falls down a tube and hits the switch to turn on the kettle. In this step, the gravitational potential energy of the marble transforms into kinetic energy as it free falls down a tube, which then the kinetic energy converts into electrical energy, which turns on the kettle. Step 14, the water in the kettle starts warming up and boiling, and when it's done, the button on the kettle turns itself off. The thin metal piece attached to the button moves as the button turns off and pushes the small marble in front of it on the road. Step 15, the marble starts moving and hits the first domino and thus sets off a small series of dominoes. Step 16, the last domino pushes on a larger marble, which starts to go down a ramp with a small incline and hits a hammer at the end of the ramp. And lastly, step 17, the hammer standing at the edge loses its balance and free falls off the edge onto the floor, where its gravitational potential energy converts into kinetic energy. The hammer is attached to the end of the wooden piece which the kettle sits on, so when the hammer falls down, it pulls on the string through the pulley and raises the kettle. The kinetic energy of the kettle moving up converts into gravitational energy and pours hot water into the mug that already has a tea bag in it. Thus, at the end, hot tea is made. So for the first calculation, I'm going to be calculating the acceleration of the bouncy ball as it gets hit by the metal piece till the end of the road. So to calculate that, I'll need to measure the distance that it travels and the time it takes to travel that distance. So to measure the distance, I'm going to be using a ruler. Here, the measurement is going to be 17.5 centimeters. So here's the calculation, and when I timed how long it took the ball to reach the end of the road, I got 0.1 seconds. I also converted the delta D to meters, and putting all those into the equation, I found what the acceleration of the bouncy ball was. For my second calculation, I'm going to be calculating the final velocity of the hammer as it hits the ground. To calculate that, I need to measure the distance or height that the hammer falls from to the ground. To measure that, I'm going to be using a measuring tape, and I just tape the top of it on top right there, starting from 0, 50 centimeters, right here. Assuming conservation of energy, I used this formula. I converted the height to meters and didn't need to measure the mass as it cancels out on both sides. For my third calculation, I'm going to be calculating the power that the hammer generates as it falls from the top of this wood to the floor. First, I weighed the hammer, which turned out to be 1.2 kilograms, and I used that mass to find force and force to find work. Then I calculated the time it took to hit the ground using the final velocity I found for the last calculation, calculation number 2, and then using that delta T value and the work value, I found power. And for my fourth and final calculation, I'm going to be calculating the maximum height. So after catapulting it, I just taped the tape measure down on the floor. I timed the catapult, I got 0.78 seconds. I divided that by 2 and took VF equals 0, as those will be the values at the max point. Using these and acceleration, which is g, I found maximum height. Then I used that value as well as 0.78 and g and found my VIY. Then I used 0.78 and the range I measured to find VIX. By taking the inverse tan of VIY over VIX, I found the value of theta.